This is a question about standard electrode potentials, and the question then goes on to link the electrode potentials with the power of something to be an oxidizing or a reducing agent. So it says the standard electrode potential for some redox systems involving vanadium are shown below. They're labelled A, B, C and D. And there are 4 equations and each of them has got an E0 value. It says which of the vanadium species shown in A, B, C and D is the most powerful oxidizing agent. So the most powerful oxidizing agent is the thing that wants to gain electrons the most. Because remember, the oxidizing agent is the thing that gets reduced. The oxidizing agent is the thing that gets reduced. It's the thing that wants to gain electrons most. So if we look at all of these values, the one that's got the largest E0 value is system A. So the vanadium species in system A is the VO2+. So going back, why is that? Because the E0 value for system A with the VO2+ has got the largest E0 value. So that means the VO2+ wants to gain an electron really badly, which makes it a really strong oxidizing agent. Second part says a student wishes to set up a cell with a standard electrode potential of 0.60. Which of the two systems A, B, C or D should he choose? Now to do this you need to find the two systems that when you add one to the negative of the other will give you 0.60. So if we look at this, by inspection you can see that the two numbers that when you would add together with a negative another would be B and D. Why is it B and D? Well, if we circle them, the most positive of these will go forwards. So there are two values here, 0.34, 0.26. So this reaction is going to go that way to give us 0.34. This reaction, the minus 0.26, is going to go backwards. So the overall standard cell potential of these two systems would be plus 0.34 from the VO2 plus 2H plus E going to V3 plus H2O. But this reaction, this half cell goes backwards, and because it goes backwards, it goes V2 plus go to an electron plus V plus. So that would make minus 0.26 volts. And it's minus because that reaction goes that way, and the minus 0.26 is when the reaction goes from left to right. Add those two together and you get 0.60 volts. Finishing off, it says complete labelling of the following diagram which shows the cell with a standard electrode potential of 0.6 volts. So these are electrodes, they're platinum carbon. This thing here is the salt bridge. And in one side of this we're going to have our V2 plus V3 plus system. And in the other side we're going to have our VO2 plus V3 plus system. The question is which side do you draw them in? Well, convention is the thing on the left hand side, that's where you put the thing that's being oxidized. So the thing that's being oxidized is the V2 plus V3 plus system, it's that one. And the thing that's being reduced is the thing that's gaining electrons, which is the VO2 single plus H plus slash V3 plus. So that system there is being reduced, that system is being oxidized. So on the left you write the oxidation, and on the right you write the reduction. So reduction's on the right, reduction on the right.